RIP in the last session. Before going with the new protocol, let me brief about RIP protocol. Before RIP, we have discussed about subnetting, right? Before subnetting, static routing is started. What is routing? Routing is a process of moving IP traffic from one network to another network. By moving the traffic, we can enable communication from one LAN to another LAN. Right? So when traffic is moving from one LAN to another LAN, it involves two basic activities. One is finding base routes, forwarding packets through base routes. The routing function. So this method of routing is a static routing, dynamic routing, and default routing. So we clearly discussed about static routing. Static routes are configured, maintained, updated by network administrator manually. And to configure static routing, administrator should know destination IP address, right? If any changes in your static routing, there is no automatic updates. Manually, we need to update. Like any changes in your network topology, manually we need to update. Means there is no automatic updates in static routing. In case of dynamic routing, destination no need to configure. Destination is not required. Destination address is not required. Only the directly connected network information is enough to configure all dynamic routing protocols. And finding base path automatically. Finding second base path. If base path is no longer available. Any changes in network topology, automatic updates. So now compared to static and dynamic, which routing is best, guys? Static or dynamic? All of you wrong. See, compared to static routing and dynamic routing, always static is best. Pradeep, you are right. What are the two advantages of static routing compared to dynamic? What are the two major advantages of static routing? In static routing, like who is finding the best path? Network admin will find the secure path. Network administrator will choose fastest path. Network administrator will choose reliable path. So means it's a more secure. Secure is more than static routing. And moreover, in dynamic routing, we have automatic update. Like any link is fails, like all routers in the network will start sending update packets. Hello neighbor router, your link is down. Hello neighbor router, my link is down. Like all routers. In your network have 100 routers. With respect to each router, will send the automatic updates. Any one interface is been down. If any one of the interface is being active, again all 100 routers will start sending updates. Like any changes happens in your network topology, all routers will start sending update packets. So to send these update packets, your dynamic routing protocol utilize your network bandwidth. Your dynamic routing protocol consumes your network bandwidth, right? So this bandwidth you have purchased from service provider, but your dynamic routing protocol is utilizing it. But in case of static routing, no automatic updates. It means what? There is no wastage of bandwidth. So whatever you have purchased bandwidth from service provider, like complete bandwidth you can use to data transmission. No wastage of bandwidth in your static routing. So compared to dynamic routing, static is secure. Compared to dynamic routing, static routes are faster. Fastest routing, right? But the thing is, static routing is recommended for what type of networks is a small network. Is a medium and large networks, and you can go for what? Dynamic routing. Right? So dynamic routing, what are the types of dynamic routing? In dynamic routing, we have two major types. Dynamic routing have two major types. What is IGP and one more is EGP. Interior gateway protocols and exterior gateway protocols. And IGP types are what? IGP types are distance vector protocol, link state protocol, advanced distance vector protocol, and EGP type is a path vector. Like distance vector protocol is a which protocol comes under here? RIP, IGRP. So this protocol comes under what? Distance vector protocol. OSPF and ISIS and DVP. Like advanced distance protocol is a EIGRP and path vector one and only protocol is BGP. So these all are types of protocols we have. Right? So last session RIP is clearly discussed. Like before RIP we have IGRP. IGRP is being outdated, is modified into RIP. In RIP also we have a two versions, RIP version 1 and RIP version 2. RIP version 1 is also outdated. Somewhere we use what? RIP version 2 only. Before we have a ISIS. ISIS has been outdated. We are using what now? OSPF, EHRP and BGP. So in our CCNA syllabus we have OSPF protocol only. But we used to teach about RIP also, OSPF also. Right. In dynamic routing protocol, we have a class and classless. So what is a classful routing protocols and what is a classless routing protocol? Classful and classless. Classless accept subnetting. Okay. Right. Let me ask some questions here. 10.1.1.1/8. Which class IP address is this? Class A. Okay. 10.1.1.1/16. Which class IP address is this? No answer, right? Ram is answered A. Wrong IP. Why? Why Pradeep it is wrong IP? Fine. 10.1.1.1/24. Which class IP address is this? Like 10.1.1.1/29. Which class IP address is this? So what is the difference between first IP address and remaining IP addresses? So first IP address we have used what? Default subnet mask. Class 8 for class A. Default 255.0.0, right? So means first IP address is not customized. First IP address is not subnetted. If it's not subnetted, then you can say, okay, it's a class full. The full is what? Class A. We can surely you can tell it's a class A. But remaining three IP addresses are subnetted, customized. So once IP address is customized, so we cannot say it belongs to A or B or C. It's classless. So only a single point, any IP address is being customized. If it's subnetted, then no classes. Classless, that's it. So as long as IP address is not customized, is not subnetted, then only we can say like 10 dot, as example, 172.16.1.1 slash 16. Which IP address is classful or classless? Yes, guys. 172.16.1.1 slash 16. Is it classful or classless? Classful, exactly. Like 192.168.2.1 slash 29. So what about this? Is it classless or classful? Classless. Why? Why? Because they're customized. Slash 29, right? It's subnetted. So once IP address is being subnetted, you can say what? Classless. So classful routing protocols does not support for subnetting. Classless routing protocols supports for subnetting. So those protocols are RIP version 1 is a classful routing protocol which does not support for subnetting. RIP version 2, OSPF, EHRP, BGP, remaining all protocols can are support for subnetting. So even IGRP protocol is a classful, it does not support for subnetting. This is a major difference between classful and classless. So in the real time, we use only classless routing protocols. This is RIP version 2. Even RIP version 1 is outdated, even IGRP is outdated, ISIS is outdated, like this. Don't support for subnetting, right? Clear, guys? And we'll come to RIP protocol. The point here does not support subnetting, support subnetting. The next one is RIP. RIP is a distance vector protocol. The open standard. The open standard means whenever I can say open standard means this open standard means can support for multiple vendors can support. Open standard means what? Multiple vendors. Like this protocol, RIP can we can configure on Cisco routers, non-Cisco routers, like any multiple vendors can be supported. Uses well-manned 4 algorithm. Yeah, Ram. Current time, which protocol is working? That answer you need to tell. So once your dynamic routing discussion is being done, then answer you can tell. You can able to tell, right? Once you finish the dynamic routing protocol, then you can understand which protocol we use in the real time now. Okay. Right. Saying is a classless routing protocol means it support for subnetting, which is RIP version 2. Metric. So every protocol has a own metric values. So metric means the one of the calculation for to finding the best path. So RIP metric is a hop count based upon number of hops, number of routers. Going to find the best path. HOP, hand over packet count. Less number of hop is the best path. Maximum hop count is 15. If it's a 16th router, network is unreachable. Like updates via 224.0.0.9 is a multicast IP class D. RIP, what type of updates? Periodic update for every 30 seconds. We'll discuss about this point, very important. And can support for load balancing also when there is a equal cost load balance, equal paths. So let me design the topology once here again. R1, R2, R3. So this topology is a hub and spoke topology, right? This is a star topology. So what is the drawback of this topology? If link between R1, R2 is fails, no communication, single point of failure. To avoid, what I'm doing is I'm making one backup link from R1 to R2. Let me take one is a line from R1 to R2, R3, backup link, the port numbers. First one is serial 0/0. So when you are practicing in Cisco packet tracer, guys, you are getting confused here only. So try to remember you are connected to which port number. So there's a reason I already inform you. So first, make one clear picture on your white paper, and you can implement your practicals, right? You're getting confusion. You're doing the practicals, okay, but the numbers you're getting confused. R1 serial 0/0. In R2, let me connect 0/1. R2, one more link, 0/0. Here 0/1. In R1, 0/1 to 0/0. This is my topology. And we know already IP condition, right? So let me assign the IP address based upon the condition for fast Ethernet IP address 192.168.2.1, R2 10.0.0.1, for R3 192.168.3.1/24. This /8 is also /24. What is mean by /24? Is a classful or classless? Is a customized or not customized? Classful is not separated, right? So my examples, I am using classful, not customized. Okay. Now WAN links, WAN interfaces here 18 dot something. Let me open my network topology. Based upon the network topology, we'll assign IP addresses. WAN interfaces IP address we have assigned public IP address 61.1, right? Okay, example 60.1.1.1/8. Here 60.112/8. Here 70.111/8. 70.112/8. Backup link, let me configure 80.111/8, 80.112. The same topology let me design in the packet tracer, and I'm making one backup link from R1 serial 0/1 to other side 0/0. Now let me configure IP address for 0/1. See, in R1, which interface I need to configure, guys? Here 0/0 is already configured. I need to configure now what? 0/1. So you are getting confused here only. On which port number you configure is very important. Let me configure 0/1. Enable show IP interface brief. You see here, fast Ethernet is already configured, assigned IP address. Serial 0/0 also already is configured. 0/1 is not yet configured. Let me configure it. Interface serial 0/1 IP address 80.111.250.0.0. No shutdown. Exit. Exit. Show IP route. Already static is running in my routing table. If you check show IP interface brief, 80.111 IP is assigned, but status is down, protocol down. You know why? What was the reason still is showing the down? Remote router port is down, right? To be configured the sides. Let me configure other router. Is R3. Now R3, which port number did you configure, guys? Here you can see the topology here. R3 0/1 already configured, 0/0 already configured, right? Type address is 8112. Let me configure R3 interface serial/0 IP address 8112. No shutdown. Right. Now all interface will be configured. Now here very important point is routing table. As we have discussed earlier, routing table is very most important, right, for the router. Let me write the routing tables of the routers. Is R1 routing table, R2 routing table, and R3 routing table. Is it clear now? Right, R1 routing table. So first tell me directly connected networks information. First routing table. Three directly connected networks are one LAN and two WAN ports, right? Let me draw here. One is 192.168.2.0 and 60.0.0.0 and 80.0.0.0. The three are directly connected to fast Ethernet 0/0. The second one is serial 0/0. The last one is 0/1. In R2 routing table, 10.0.0.0, 60.0.0.0, and 70.0.0.0. Three are directly connected networks. It is connected to FE 0/0 and serial 0/1, serial 0/0, 192.168 3.0, 70.0.0.0, 80.0.0.0. All are directly connected via FE00 and 70 is 0/1 and 80 0/0, right? These are directly connected networks. Now to enable communication from R1 LAN to R2, R2 LAN to R3, for all LAN to LAN communication, we need to configure routing between the three routers, right? To configure what? Routing. So this routing can be static also or dynamic also. If it's static routing, like all destination networks, we need to update manually. If it's the dynamic routing, automatically update. Now let's see how RIP is updating means. In R1 router, if we configure RIP for R1 router, which routers are directly connected? I mean, which routers are neighbor routers? R2 is directly connected. So directly connect device we call neighbor. R3 is also directly connected. So what R1 is doing is we're sending a update package. Update means what? RIP update. RIP update means routing table. like instead of routing table, you can call it as a in RIP. Complete routing table will send update. Complete routing table means in a routing table have a 3 networks or 4 networks or 40 networks, like our 400 networks also. Complete routing table will send as a update. Okay. So what RIP is doing is sending update packet. This is complete information, routing information. Hello neighbor router, take my information. Hello neighbor R3, take my information. We'll send it. But we have configured RIP in only R1, right? So means what R2 and R3 is doing is, sorry, we are not belongs to your group. We are going to drop the traffic. Not send an update packet. So if we configure only in one router, no communication. Like once if we configure RIP in R2 and R3, now 3 routers is belongs to what? Same group. Now 3 routers will start exchanging, will start updates each other for every 30 seconds. So these type of updates we call periodical updates. So let's say first example R1 is sending update to R2 router. This is an update packet sent to R2. Now what R2 is doing is we'll check the list of IP address. So for in the list, what is the first network? 192.168.2.0. In my routing table, there is no entry. So let me update it here. 192.168.2.0. So this network is manually updated or automatically updated? Automatically updated by which routing protocol? Yes. So here it shows what? R. Okay, first one is okay. Second one, 6000. You see already present is the information is not required. The last one, 8000. Let me update here. 80000 RIP update. Now what R2 is doing is, now you take my update packet, complete routing table sent to R1 router. Now R1 is going to update here. Okay, 10000 RIP updated. Now 70000 RIP updated. Now what R1 R2 will do, will someday update to what? R3 router. So for R3 router is doing is what? It's going to update here 10000 192.168.2.0 and 6000 all are RIP updated. Now here 192.168.3.0 and here also 192.168.3.0. So like this, the 3 routing tables are updated by RIP. Now R1 router, R2 router, R3 router will start communicating, right? So from here, you need to understand very carefully. So this topic is already explained yesterday, but you know why I'm explaining again? So you can more understand, right? So coming protocol, which we are going to discuss, the protocol is very important. So let me explain clearly once again about this. So try to understand clearly how RIP is working. Now, all 3 routers are being updated. There is no R4 router here to update anymore. There is no R5. Only 3 routers and 3 routers information completed to exchange. You know, now 3 routers LAN to LAN communication is enabled. Everything is going good and well. Still, you know what RIP is doing is for every 30 seconds, all 3 routers will exchanging your complete routing information. If your network is a 24 by 7, now you think about it, how much bandwidth is being utilized by RIP protocol. Every 30 minutes, every 30 seconds. Every 30 seconds. So what R1 is doing is 30 seconds. take routing table. Again, next 30 seconds, take routing table. Not only R1, R1, R2, R3. Every 30 seconds, they keep on exchanging means more and more bandwidth is utilized by RIP protocol. The first day I started my demonstration, right? Like I have introduced myself as a Balu. So I'm a senior network engineer in the Zoom technology. I just introduced. Again, after 30 seconds, so this is Balu, senior network engineer. Again, 30 seconds is Balu. And I need to introduce like this. Uh-huh. No need, right? So why? Because I already have update. My energy is wasted. My bandwidth is wasted. And when update is required, when update is required, any changes happens in our sessions, then you need to update, right? But RIP will do periodical updates. There is a point here showing a RIP sends periodic updates for every 30 seconds. Even in our disadvantage of RIP protocol, we clearly discussed more bandwidth is utilized for sending updates. So what type of update sending is what? Periodical updates. So by sending periodical updates, RIP utilizes the more bandwidth. The next point is here. Okay, utilizing more bandwidth is also one of the drawback of RIP. One more point is here. You know, if after some time R2 is being down, R2 is down, what RIP will do? If neighbor is down, so still we need to send the update packet to R2 router. No need. We just send hello neighbor, hello neighbor, hello neighbor, hello neighbor. If he's not responding, then you can make sure that you are down. Right? Same like I will ask you questions like hello, can you hear me? Hello, can you hear me? Hello, can you hear me? If 4 or 5 times if you ask the question, if there is no responding, then what I will think, okay, so you have some network issues. Something went wrong. So when I say hello, hello, can you hear me? If I get the reply, then I can say, okay, the session is okay. The connection is what? Clear. Similarly, RIP is doing is even neighbor routers fail also is keep on sending update. You keep on sending update. You keep on sending update. So when I ask the questions for you, if he's not responding, even still if I continue my class, not make sense, right? Yes or no? What RIP is doing is even the neighbor router is not responding, keep on sending update. Bandwidth is wastage. Even an update information is a same information. For every 30 seconds, same information. 2.0, 60, 80, 10. What the information we have, the same information again and again is sending. No use. Already we have update here. Then why you are sending the same information for me a lot of times here? My bandwidth is wastage. Your bandwidth is wastage. Right? So you keep on sending up to how many seconds is a up to 180 seconds RIP keep on sending update packet. Like up to 180 seconds, if there is no responding from the neighbor, then R1 can consider, okay, something went wrong for neighbor router. Okay, after 180 seconds, now R1 will come to know R2 is being down. What R1 has to do? Okay, R2 is down. Then why I need to maintain R2 information in my routing table? No need of the routing information, right? Still hold the information up to 240 seconds. Like up to 240 seconds, if there is no response, then only art information is being flashed. These all are RIP timers. These timers, RIP timers are what? Update timers. Yeah, after 240 seconds, RIP is up, R2 is up, we send the update packet, right? Update packet. Then R1, okay, you've been active, right? You can store information again. Update timer is 30 seconds. Invalid. 180 flush. 240 seconds. These all are RIP timers. So what does it mean here? It is a RIP protocol is a very slow convergence. If R2 is being R3 is down, when R1 will come to know R3 is fails? How many seconds is it? 30 seconds. Even one new router is being updated in your network. When your routing table is being updated, 30 seconds. RIP is a slow convergence. The last point here can show here slow convergence. RIP major drawbacks are what, guys? Can I repeat once again? RIP utilizes what? More bandwidth and slow convergence. Understand this network topology here. Is router A, router B, router C, router D. LAN is 192.168.1.0/24. HLAN is 192.168.3.0/24. You can reach via serial 0/0. Link speed is 10 Mbps. Serial 0/1 is 80 Mbps. And serial 0/2 is 60 Mbps. Now, in router A, if I configure static routing, as for static routing, out of three routes, which is the best one? Serial 0/1. So, as per static routing, what static routing is doing is it depends upon what network admin. So network administrator can choose based upon the speed also, based upon the number of hops also, or based upon security also, like any parameters, any other parameter, right? So we can't say exactly which is the best path. It's decided by network administrator. You can consider based upon the speed or based upon number of hop on, based upon the security, based upon the traffic. Okay. Example from Hyderabad. In Hyderabad, small example I'm telling is from Amirpet to reach some area, Banjara Hills. So from Amirpet to Banjara Hills have a one, two, three routes. The first one is a 1 km, second one is a 2 km, the third one is a 3 km. Now out of three routes, which is the best one, guys? First one. Why? Because a shortest distance. Like if you go via 1 km, time saving, like very fastly can reach, fuel saving, can reach early, right? Advantage we have some. Okay, we used to go via 1 km only. Sometime in 1 km have a heavy traffic. Heavy traffic is there, heavy load is there in 1 km. Then what we'll do? If heavy traffic in 1 km, then what we'll do, guys? We'll go via what? 2 km. Even compared to 1 km, the 2 km is a longest path, but still, due to the heavy traffic on 1 km, we are choosing what? 2 km link, right? 2 km path. Okay, we start going via 2 km, but thing is in 2 km, so there is no lights, there is no road good, like complete number of speed breakers. Road was not good. I mean to say, no secured. It's not secured. So 2 km is worst road, no security. And what we'll do, guys? So compared to 1 km, 2 km, 3 km is the longest path, but still we are choosing 3 km. You know why? Because here traffic free, road was clear and neatly, so means more secure. Right? So finally, based upon what parameters we decided 3 km is the best one. So first we have decided based upon what distance. So second we have discussed based upon the traffic. So third we have discussed based upon what? Security. So a lot of parameters considered. Then finally we have decided last one is a best one. Similarly, for your data transmission, also what network administrator doing is the network administrator can consider what is the link speed here, what is the bandwidth, and how much traffic on the link, how much security on the link. So which is a faster, any traffic is dropping, any data loss here. These all parameters can consider. Finally, network administrator can decide which one is a best path. Right? It can be 0/0 or 0/1 or 0/2. Leave it about it for network administrator. Next example is if I configure RIP in this topology, which is the best one? So based upon RIP, which is the best protocol? EBH. Why? RIP will find the best route based upon what? Number of hop counts, shortest path. Number of hop count, right? So, but if traffic is going via 0/0 ABH, your link speed is what, guys? 10 Mbps only, very low speed. Then why I need to maintain the 80 Mbps link here? Then why need to maintain the 60 Mbps here? I'm paying the highest amount, right? But RIP is not utilizing it. So RIP is telling is that even it is a 1 Mbps also, my best route is this. This is a major drawback of RIP protocol is it. RIP does not consider bandwidth in metric calculation. So when RIP is finding the best route, it does not choose the bandwidth. RIP always to find the best path based upon what? Hop count. Number of hop counts only. It does not consider bandwidth. So see the second point here is telling is does not consider the bandwidth in metric calculations, uses only hop count. So these all are major disadvantages of RIP protocol. Hope you have clear clarification about RIP now, right? More bandwidth utilized because periodically complete routing table is sending and very slow conversions like even 30 seconds, 180 seconds, 240 seconds slow conversions and does not consider bandwidth in metric calculations. So we is not considered, right? And there is a limited hop count. The limit is maximum 15 hops. Okay, 15 hops only. If it's 16 hop, your data packet, IP packet is being marked as a unreachable, right? Network unreachable. And the drawbacks of your RX protocol. Now, let me start. One more protocol is link state routing protocol. So this protocol we call LSP. All of you can hear me clear? Let me shall I start the new protocol now? Right. LSP. What is the L, please? L means what? L is a link, right? What do you mean by link? Link means what? Connectivity. Okay. Connection. Okay. Attachment. Okay. Come to this topology here. Network topology. R1 router A is maintaining the routing table. For router A, fast Ethernet 0/0, serial 0/0, serial 0/1, serial 0/2. Like total, how many interface in the A router? Router A, total how many interfaces is there? 4 interfaces. The first one is FE 0/0, serial 0/0, serial 0/1, 0/2. Means link is nothing but router interface. Like for router A, how many links are available? 4 links. I mean, 4 interfaces. Number of interfaces is equal to number of links. Link means interface. So router A has a how many links are available, guys? 4 links, right? Now, if we configure link state protocol in A router, what A is doing is like which routers are neighbor routers for A router? For router A, which routers are neighbor routers? B, C, D is the neighbor, right? Like what A is doing is, hello neighbor B, I have a 4 links. So take my 4 links information. 4 links information nothing but so L is link. Link means router interface. What do you mean by yes? S means what? State. Means status of interface. Link status, router interface status. Status means a link is a active, a link is a down or admin down. So what was exactly status of interface? So this information will be advertised to neighbor. Hello neighbor B, I have a 4 links and the 4 links information I'm updating to you. Right. Have a one more neighbor. Hello neighbor C, have the 4 links. Take my 4 links information. Okay, right. So I have one more neighbor D. Hello neighbor D. So take my 4 links information. Right. So with respect to each router, will advertise all the links information, links status information. So this protocol we call LSP, link state protocol. For example, what about router B? For router B, how many links are available? As per this topology, this diagram, 2 links, right? Now what B is doing is for router B, H is one neighbor and A is one neighbor, right? So what B is doing is, hello neighbor H, take my two links information. Hello A, take my two links information. That is the first point here in link state protocol. Every router maintains full picture of the topology. In your network topology, so with respect to each router should maintain full picture of the topology. Means router A should maintain router B links information, router C links information, router D links information, and router E links information, router F links information, router D and router G and H. Not only A, like router B also should maintain all routers links information. Router C should maintain router D, like with respect to each router. Telling is what? Every router maintains what? Full picture of the topology. Like if you log into any one of the router, you can get all the links, all the routers information, links information. In which topology? LSP, link state protocol. If your organization, if your company's maintain, if your company is configured with LSP, now as a network engineer, if you log in any one of the router, you can get all remaining respective remaining all routers information also. Right. Second point is here, link state protocol is more scalable. The more scalable means, so this link state protocol we can use for small networks, and we can configure in a like a medium networks, large networks, and very large networks. It can be support for any size of the network that we call more scalable. It can support for what? Small, medium, large, very large, enterprise. Any type of network can be supported. Any change in the topology is quickly updated, which is very, very important point in your link state protocol. What type of updates in your link state protocol is a quickly? If R1 has a one link, serial 0/0, and one more link, serial 0/1, one more link, pass Ethernet 0/0. For R1 router, serial 0/1 is a fails. So what R1 is doing is immediately trigger quickly send update to neighbor. Hello neighbor R2, one of my interface is down. In which type of topol, in which type of network is a link state protocol? If it's a RIP protocol, what RIP will do? If serial 0/1 is down, after 30 seconds, we'll send an update packet to neighbor. Hello neighbor R2, my one of the interface is been down. Along with serial 0/1, what R1 will do? What are the interfaces in your routing table? Have a 30 networks or 300 networks. All networks will send to R2. Event has what? Serial 0/ is a down information. I mean to say, complete routing table used to send RIP protocol after 30 seconds, slow conversions. But OSPF, I mean, link state protocol is what? Quickly updates, instantly trigger. Link is down, send updates immediately. So similarly, like this, compared to link state protocol has more advantages compared to distance vector routing protocol. Uh, let me discuss clearly one by one what are the more advantages. Okay, guys, you can copy this slide now. Which protocol is a next one is OSPF, which is open shortest path first. We discussed about link is route interface, state is status of interface. OSPF was open standard like RIP protocol. Multiple vendors can support. Uses Dijkstra. Algorithm name. The scientist name is what? Dijkstra. Or we can call the shortest path first. SPF algorithm. Classless routing protocol support for subnetting is not a class full, but classless routing protocol means it can support for class full and classless both can support. Okay. See how RIP will find the best path. RIP will find the best path based upon what? Number of hop count. Is it advantage or disadvantage, guys? Disadvantage. Why? Because it does not consider the bandwidth, right? The drawback of RIP protocol. In drawback of RIP protocol, we clearly discussed about what does not consider bandwidth in metric calculation, uses only hop count. Right? But you know, OSPF protocol will find the best path based upon the bandwidth. In one network diagram, so ABH link speed is a 10 Mbps. Via serial 0/0 is a 10 Mbps. Via 0/1 is a 80 Mbps. Via 0/2 is a 60 Mbps. Now, if we configure OSPF, what OSPF is doing is 10 Mbps, 80 Mbps, 60 Mbps. Okay, 80 Mbps is my base route. So OSPF will find the best path based upon what? Bandwidth. So this bandwidth is to calculate by using one formula that we call cost. Cost formula is a 10 to the power of 8 by bandwidth in bits per second. So this formula only for Cisco devices. Cisco router sector. We call metric of OSPF is what? Cost. 10 to the power of 8 by bandwidth in bits per second only for Cisco. So we have a next session, we'll discuss clearly about this bandwidth calculation. So just keep in mind, OSP will find the best path based upon what? Bandwidth, but actually technical terminology is what? Cost. Right? Like updates. Generally, RIP updates are what? 224009 is a RIP update. 224005 is a OSPF update. And OSPF protocol can support for load balancing. You know how? Example, serial 0/0 is serial 0/0 is a 80 Mbps speed. If serial 0/1 is a 80 Mbps. If 0/2 is also 80 Mbps. Now out of three, we configure OSPF, which is the best part. 0/0 or 0/1 or 0/2, which is the best part? All are best routes. So your traffic is being load sharing, load balancing. Traffic can go via three routes. So how RIP support for load balancing? Like OSP was support for what? Load balancing when for equal cost. It may mean equal bandwidth. If three interface has a equal bandwidth, the OSPF protocol supports equal cost load balancing. Administrative distance for what? Distance what? 10. Hello, can you hear me? Right. So now compared to RIP, what we have advantages in this topology in this protocol? The first point is quickly updates. One more is a metric. It can consider bandwidth. Native value is a 110. Okay. But compared to RIP is open standard. OSP was open standard. RIP support for subnetting. I mean, classless is also classless routing protocol. RIP support for load balancing and OSP was support for what? Load balancing. But what are the advantages of compared to RIP and OSP is RIP slow convergence after 30 seconds update, but OSP is what? Quickly updates. RIP does not consider bandwidth in metric calculation, but OSP will consider bandwidth. Based upon bandwidth, OSP will find what? Best. Not only this, we have major advantage. More advantages is there. Let me clearly discuss the more advantages. So listen carefully, all of you here. In this network, configure RIP. RIP is running now for three routers: R1, R2, R3. Three routers. What R1 is doing is blindly, even neighbor R2 and R3 are active or down, whatever it does not consider. If RIP is configured, we'll start sending complete routing table for every 30 seconds. Right? So means maybe if R2 is down, what R1 do? It's still sending some update packet. And with this wastage. So when I'm asking questions to you, can you hear me? Are you understanding? If you are not responding, it's a waste of my time, right? What RIP is doing is not does not consider your neighbor is active or not. So once RIP is configured, we start sending updates. Even if I'm doing like this, once class is being started, like one way continuous, I'm speaking, continuous, I'm speaking, doesn't make sense, right? Every few minutes, I used to asking you questions like, can you hear me? Are you able to understand? Are you getting reply? Open the chat box and send me the reply, right? It makes sense. But RIP will don't do like this. Complete routing table, sending update package. But you know how OSPF is doing is OSPF is very intelligence protocol. What OSPF is doing is before sending updates, I mean routing information, links information. If we configure OSPF here in R1, what R1 is doing is before exchanging the database, before sending the database to neighbor router, what R1 is doing is so first R1 will come to know neighbor routers are active or not. Yeah, similarly, three-way handshake model, but not exactly three-way handshake process. Similarly, not exactly. So three-way handshake process in TCP protocol. Okay. Similarly to TCP, but not exactly. Okay. So what OSPF is doing is going to make sure to R2 and R3 is active or not. So now you tell me, guys, how I can make sure you are active or not. Hello. What? Reply. So when I asking, responding, like hello communication, exactly, Mustafa. Perfect. So what R1 is doing is to know R2 neighbors is active or not before exchanging the database. We'll send one normal packet called hello packet. Send what? Hello packet. Hello neighbor 2. Hello packet. Similarly, hello neighbor 3. But inside the hello, there is no networks information. There is no database. It's just sending what? Hello packet to neighbors. For what purpose? To make sure neighbors are active or not. If R2 is giving the reply, Yeah, hello R1. If auth is given a reply, hello R1. Like after exchanging hello packets, now R1 will come to know R2 is okay. Now R will come to know R1 is okay. Now R1, R2 become the neighbors. Like once neighbor is being established, then okay, now take my links information. Now what R2 is doing is okay, now you take my links information. So then only they can exchange the database when after neighbor is being established. So to establish the neighbor, what mechanism they are doing here? Is exchange routing information. So to exchange the routing information, I mean routing information, the RIP, forget about it. So here come to links information. We are discussing about which protocol here? LSP, links information. Right? Like before exchanging links information, what R1 is doing is they are going to make sure our neighbors are active or not. So neighbors are active or not to know that what mechanism they're using. Hello communication, hello packets. So once neighbor is being established, then only database information has been exchanged. So to enable neighbor relation, what they're exchanging means hello packets. So these hello packets for every 10 seconds they used to exchange. Means every 10 seconds they're making sure you're active or not. Right? Like how I'm asking frequently for questions. Similarly, OSPF will make sure for every 10 seconds hellos are active. To maintain the neighbor, to maintain the neighbor relation, the exchange what? Is a keep alive mechanism for every 10 seconds exchange what? Hello neighbor, hello neighbor. Let's say R2 is down. Example, R2 is being down. What R1 is doing is hello R2, hello R2, hello R2, hello R2 for every 10 seconds. Up to 4 seconds, 4 consecutive hellos. If there is no reply, now R1 will decide R2 is no more, R2 is dead. Now flash the routing table information. How many seconds, guys? 40 seconds. But RIP protocol, 240 seconds. So compared to RIP, OSPP is what? Fast protocol. So this also will say very good advantage of OSPP is OSPP has hello packet mechanism to maintain the neighbor relation to make sure neighbors are active or not. Correct? But RIP will do what? Blindly, if your neighbor is down also, sending update for everyone. The first advantage is a quickly updates. And second one is it maintains a neighbor relation by exchanging hello packet mechanism is available. And fast protocol, within 10 seconds neighbor is been established. And within 40 seconds neighbor is being down, like flash information. And very, very important point in the OSPF protocol is in interviews they can ask. Surely, very important point is here type of updates. RIP will send every 30 seconds the same information, right? We call it as a periodical update. The reason there is a reason RIP utilizes the more bandwidth, but OSP will do not like that. So what OSP is doing is once routing tables are being updated, with the help of WO, whatever here we have R, protocol is OSPF, it is being replaced with O. Code is what? OSPF. Now, once routing tables are updated, no information, no database exchange, no updates. When update will start here, when there is change in your network topology, then only updates. There is no periodical updates in what? OSPF. In OSPF, When there is a change in topology, then only update. If, like example, R4 is being added, I have some changes, right? Now we'll send update packet to R2, R2, R4 is added. Like R2 will send update to R1, R1, R4 is added. Even if a link fails, like serial 0/0 link fails, then update. So when there is a change in topology, then only update. If there is no changes, no updates. So this type of updates we called incremental updates. In RIP, periodical updates. In OSPF, incremental. So incremental update means what, guys? When there is a change in topology, then only update. If there is no changes, no updates. Okay, getting the point? So now back to RIP. Yeah, let me explain Mustafa clearly. RIP update is what, guys? RIP update. RIP update is what? Complete routing table. Type of updates are periodic, but what is update? Here two questions. One is what type of updates and what is update? What type of updates in RIP is a periodical? What is updating is a complete routing table. In OSPF, what type of updates? Incremental. When there is a change in topology, then only. Now let me see here in OSPF, what is update? What is update packet contains? In OSPF, if serial 0/0 is down, serial 0/0 is a file down. Now in update packet, inside the update packet, we have these information only. There is no complete routing table information. Which link is been failed? A particular link information only in update. Even my routing table have a 100 networks or 200 networks or 300 networks. OSP will not send update to complete routing table like RIP protocol. What OSP will do? Will send only which link is being failed. Particular link only. So this update we call, what is serial 0/0 means in technically? Serial 0/0 is a L. L means what? Link. Good. Then what is down means what, guys? Up or down means what? Status. Status, right? So this update we called LSA. Link state advertisement. Link means which interface is being happened, and state is a up or down. What was exactly status of link? This information is being advertised to neighbor routers. OSPF updates are what? LSAs means link state advertisements. But what is update in RIP protocol? In RIP, complete routing table is update. In case of OSPF update is what, guys? LSAs, right? Link state advertise. Which is the best? So which protocol utilizing a more bandwidth here? By sending complete routing table or by sending only one link information? So RIP sending a complete routing information means 200 networks or 300 networks, whatever complete routing table is sending update for every 30 seconds means RIP utilize more bandwidth. But OSP will do not like that, right? Sending only which link is being failed, that information only will send. And moreover, when there is a change, then only it is not even for every 30 seconds or every 2 seconds. Incremental updates. That update is also not even after 30 seconds or not after 40 seconds, is a quickly incremental trigger updates. Very, very, very good advantages, right? Got the point? See here, if we compare to type of update in RIP. Periodic updates. RIP is periodic updates. In OSP is what? Incremental updates. In RIP, have a R1 router, R2 router, R3 router, R4 router, like R15 and R16. If traffic is being generated from R1, so this data traffic can hand over up to which router? Can cross up to which router, guys? 15th router only, right? But if it's a OSP of can reach how many? What is the maximum hop count of OSP? We say 16, right? No. How many routers? 160, 1600, 16,000. So there is no limit in OSP of it can support for unlimited hop count is very good advantage of RIP has a limited. The limit is what 15 only. But if you configure OSP of number of routers can be crossed. How you can tell so which routing protocol we use in the at present in the real time, your IT companies, your railway department. Yes, exactly. Minas is outdated. RIP is outdated. So you know why? Why? Because RIP periodical updates so much bandwidth utilized, slow convergence does not consider bandwidth. But OSP of incremental updates only changes is update. It's considered the bandwidth. It support for unlimited hop count. It's a fast protocol. It maintains the neighbors. Right? It's all advantages. Now come to theory class reference. Neighbor is discovered and established by hello packets. Hello packets for 10 seconds. Rate timer is what? 40 seconds. Support for unlimited hop count. OSPF sends updates LSA when there is a change to one of its link. LSA means what, guys? Link state advertisement, right? OSPF protocol number 89. Yeah, guys. As of now, have any doubts regarding to OSPO? It's open standard, PF algorithm, support for subnetting, concept bandwidth, multicast address, support for equal cost load balancing, and AD value is 110. And compared to advantages, hello packets are supported to maintain the neighbor, and hello timers are 10, day timers are 40 seconds. Support for unlimited hop count. Let's say incremental upgrades. It's all about OSP. Let me continue with the OSP of terminology. Can you hear me, all of you? See, one good scenario let me discuss here. This is my router. For every protocol, we have a number actually. TCP protocol, UDP protocol, and IP protocol, and like the OSPF protocol and EIGR protocol. Protocol is being identified by port number 80. Like you have the port numbers, right? Like every protocol is being identified by 8. Like EIGRP protocol is 8 numbers for device identification purpose. Okay, now come to here, router 1. Name is R1. R1 has a FE, fast Ethernet port. Number is 0/0. R1 router has a serial port 0/0 and one more port serial 0/1. And routing table, R1 has a how many links in R1? The links in R1, 3 links. One is a serial 0/0, serial 0/1, and FE 0/0, right? So the 3 links and the 3 links are being directly connected in my routing table. I need a one more interface, one more network in my routing table. How we can get? For R1 router have a 3 interfaces, then I'm getting the 3 networks information, but I need a one more network. Serial 0/0 is a 6000 network. It is a 7000 network. It is a 10000 network. So 3 interfaces, 3 network IDs, but I need a one more network information, one more network ID in my routing table. How I can get? Connect serial 0/2. Okay. Okay, let me add one more interface, serial additional port, active additional port. Okay, right, Rakesh. Serial 0/2. Okay, serial 0/2 have attached. Added. For serial 0/2 connected, network is something 80000. Right. So for R1 now have a 4 interfaces. I mean 4 links. I'm getting 4 network IDs. I need one more network in my router. How we can get? Like I need a 100 networks in my routing table. I need a 100 networks in my routing table. How we can get? Add more routers or add more interfaces? Add more interfaces, right? How many interfaces I need to add? I need a 100 networks. Then how many interfaces, right? Interfaces, right? Hmm. Hello. Thank you. No, actually, I have stopped speaking. I'm taking a chat box. Okay, Nikhil. Right, you can ask me question like why Balu you need a 100 networks in the routing? Why I need a 100 network? The last practical, the last class is what? RIP. Have we configured RIP? Practiced on RIP, right? No. Okay. What do you practice? Can tell me. As we had discussed RIP, what type of updates? Periodic update. For how many seconds? 30 seconds. What RIP will do? Will send complete routing table. And each update contains maximum how many networks? 25 networks. 25 networks. Mean in my routing table, if I have a 100 networks, then what RIP will do, guys? We'll divide into 4 updates. 1, 2, 3, 4 updates. First update for 30 seconds. Next update for next 30 seconds. Next 30 seconds. Next 30 seconds. Like, have we tested this? Have we tested, guys? No. Right? We just configured our IP. That's only, right? So we need to test it. Like how RIP is working. Like he's sending the 30 seconds, he's sending complete routing table, he's sending maximum is 25 networks. How much time is taking for one update to another update? Like we need to test RIP protocol. Similarly, we need to test OSPF also. What type of updates is sending like OSPF also. So to testing the protocol, we need to maintain 100 networks in your routing table. At least we need to maintain how many networks in your routing table minimum. Let's say 30 networks. You have a 30 networks in your routing table. What RIP will do now? First 25 networks will send as a first update, and remaining 5 networks will send as what? Second update, right? So to testing RIP, so at least how many networks we need in the routing table? 30 networks. Like how I can get 30 networks in my router? Means 30 interfaces we need to add, right? How many interfaces per router? Like maximum is depends upon the model numbers, categories, ISP router, network edge router, branch router. You have model numbers, right? Example, 9000 series router, 6000 series router. This router can support for 30 interfaces. Not 30 routers, 30 interfaces. Yeah, it depends upon not maximum. Like how many we can say we can add more and more interfaces for modular routers, right? We can add more. Okay, 9000 series router, which is ISP router. What is the price of ISP router? Cost. The price of ISP router. 1.25 lakhs? No. 1 CR. 40 lakhs, 80 lakhs. 1 CR you can go, right? Example, like crores. Okay, 1 CR. So 1 CR router we are going to purchase for what purpose, guys? For what purpose? Interface. Okay. Why we need interface? Yes, Rakesh. For what purpose is a testing purpose? Right? For testing purpose, we need to purchase 1 CR router. Once your RIP testing is finished, then what will you do with router, right? Not like that. We no need to purchase. We no need to purchase. Okay. So we'll do Balakrishna will do. Right. Jokes apart. Even your normal branch office router can be 2600 router, can be 2800. Any model number, any router. We no need to add a physical interface. Don't add the physical interface. You have purchased one 2600 router. You have a fast Ethernet port and you have a two WAN ports. I know. Means how many interfaces, how many networks you can get here? Example, which already copied here, R1 router. How many are you getting here now? Serial 0/4, right? 4 are physical interfaces. Okay, now enough. So what we're doing is inside the router we can create virtual interfaces, which we call loopback interface. Loopback. So these loopback interfaces we used to create only for what? Testing purpose. So by default, there is no loopbacks in your routers, but we can easily create and we can easily delete also once your testing is been done. So loopback interfaces only for testing. So by using loopback interfaces, a data transmission is not at all possible. So data transmission can be possible through only what? Physical ports. Loopback interfaces, the major reason, the major purpose of loopback interface is what, guys? Only for what? Testing. Let me show you how to create this loopback interface. Let me log into branch office 1. Show IP interface brief. At present in the branch office 1 router, how many interfaces are available here? Three. So 3 are physical interfaces. Serial 0/0/0/1 fast. Now if I open routing table, we do one thing. Let me remove the static configuration. Let me remove the static routing. What I'm doing is let me copy this all configuration. No command and paste it. So run. We have one more static UTC. Copy. Configuration mode. No space. Okay. Yeah. Now if you check, show IP route. I have only 3 directly connect networks, right? Serial 0/0/1 3 interface. But I needed 30 networks in my routing table. So instead of adding physical interfaces, what I'm doing is let me configure virtual interface, which is loopback interface, loopback number 1, IP address. Any your example, you can use any IP address. Example 19.111.2500. Interface loopback 2, 18.1.1. Interface loopback 3, 17.1.1. Now back to previous mode, show IP interface brief. So at present now, how many interfaces are available for my router here? So total are 6 interfaces, right? Like out of 6 interfaces, how many are physical and how many are virtual? 3 physical interfaces and 3 virtual interfaces, which is 3 loopbacks. If you open the routing table, show IP routes. The routing table has the 6 networks. Even we can add the 7, 8, 9, 10, like n number of loopbacks can be created. Make your routing table is a 30 networks. Make your routing table is a 300 networks also. Then you can start run your RI protocol and you can test it. How updates is been going there. So once your testing is been finished, then we can easily remove. What is the command? You can tell me. No interface loopback 3. No interface loopback 2. No interface loopback 1. That's it. Remote. Now again, show IP route. We have default 3 interfaces. So loopbacks are only for what? Testing purpose. Loopback interface configuration and copy it in router configuration mode. You can use command interface loopback number 1, and it can take you in a interface mode. You can assign IP address directly. For example, can be any IP address, it can be any subnet mask. Simply can use command is in exit. Even no shutdown command is not required. So no shutdown command only for what? Physical interfaces. Physical interface is the down state. You can use what? No shutdown. Default is shutdown. We can use what? No shutdown. But loopback interface, once if we create loopback interface is always active. The reason we can give the high priority for loopback section. Okay, guys. Now back to our main topic. If we continue OSPF now, OSPF support for unlimited hop count, right? So support for unlimited hop count means which type of network topologies OSPF is recommended. Small networks or large networks? OSPF support for what? Unlimited means it support for what? Large. Large networks is recommended. So large network means, let's example, SBI is there. Like overall India wide, as we have discussed, we have 14 or 15, like 14,000 branches all over India. Like 14,000 branches, if we use, if we recommend static routing, no. Or do you recommend RIP? No. Then which protocol is the best? OSPF. In OSPF, how many networks are available here? 14,000 branches. So means how we can identify each router in OSPF network. It's a very large network, right? So how to identify a router in OSPF network means every router has a ID. That ID we called router ID. The router is used to identify a by using one ID called OSPF router ID. So what will be the OSPF router ID? R1. Name cannot be ID. R1 IP address 10.0.0.1. R1 serial 0/0. IP address is 186.1.1.1. R1 serial 0/1. Interface is 186.2.1.9. Now, what will be the OSP of router or ID of R1? Name cannot be ID. You know why? Why? Because in our participants there are like a lot of persons. Let's example Rakesh. In overall worldwide, the name is only one person is a Rakesh. Many members is the right name. It's a common name. Then how we can identify the person? Okay, let's say He is a K Rakesh. Can be same. Is a unique name. K Rakesh. Number of people is a K Rakesh. Okay, date of birth. Date of birth also same time, the same date. So many members is been. Even surname is also similarly, right? Maybe his father name also similarly. Name. The name cannot be a identification. What is the unique identification means what? Number. Number is identification. Yes, other number is identification, right? Whatever. Any other number or a passport number or any number is identification. Okay. Similarly, here to identify a router in a OSP of network, what will be the ID means? Router name cannot be ID. R1 or host name cannot be ID. It also is what? Address of the router is the ID. But R1 has a 3 IP addresses. Fast Ethernet, serial 1, serial 0, like 3 IP addresses. So what will be the R1 router IP address means out of 3 IP addresses, which one is a highest number? 186.1.1 is the highest, or 186.219 is the highest, or 10.0.0.1 is the highest. Which is the highest? 186.2.1.9. So highest IP address will be the router ID. Now for R1 router ID is a 186.2.1.9 is a RID, router ID. Okay, guys. Now R1 is connected to R2 router. Now R2 router LAN interface. Fast Ethernet is a 192.168.1.1 and R2 serial interface IP address is 186.2.1.10. For R2 router, what will be the router ID, guys? 192.168.1.1 is a router ID. Perfect. Now, after some time, I have configured R1, L1, and L2. I mean, loopback 1 and loopback 2. Two loopbacks are configured. Now, R1 loopback 1 IP address is a 18.1.1.1. L2 loopback 2 IP address is a 19.1.1.1. Like total, how many interfaces in an R1 router? How many IPs in R1 router? 5 IP address, right? Like out of 5 IP address, what will be the router ID of R1? 186.2.1.9 is not a router ID now. You know why? So why? Because once if we configure loopback, now priority will go for loopback interfaces only. If there is no loopbacks are not configured, if there is no loopbacks, then only RIP can consider highest sorry, OSP can consider highest physical interface IP address. But now we have configured loopback, right? Now OSP is doing is go for loopback 1, 18.1.1, loopback 2, 19.1. Now your router ID is what, guys, here? 19.1.1 is a router ID. Now you tell me, guys, why we have created 19.1.1.1 IP address? What purpose we have created 19.1.1 IP address? I mean to say, for what purpose we created a loopbacks for testing purpose, but OSPF is consider this IP address as a ID, router ID. We don't want. After some time, we used to remove it, right? So we just configured for a testing purpose, but OSPF is taking serious on it. So 19.1.1, you are my router ID. I don't want 19.1.1 as a router ID. Then manually we can give router ID command. You can configure router hyphen ID. Let's say 2.2.2.2. Finally, what will be the router ID of R1 router? 2.2.2 is a router ID. If router ID is not configured, what is the router ID? Loopback. If loopbacks are not configured, then what is the router ID? Perfect. So here, first preference. OSP of router ID, first preference for what? Router ID command. Second preference for what? Highest loopback interfaces. Second preference for what? Third preference for what? Highest physical interface ID. Router ID is used to identify the router in OSPF. First preference given to router ID command. Second preference is given to highest loopback interface configured on router. Third preference is given to highest physical ID. Any ID, 2.2 is not fixed. My example is 2. 2 is my example. You can use any IP, there's no issue. You try to find out in this topology what will be the router ID. One nine two 116. You know why? Why? Because there is no loopbacks, there is no router ID command. Then preference will go for what? Highest physical interface. If I created a loopbacks, now 12.001. If we configured manual router ID command. Yeah, there should not be same networks for two interfaces. If you try to configure to interface the same network, it comes like it overlaps. Sorry. Here, here 172.16.0.2 and here 172.17. What are the different networks? Right? No problem. No issue. Okay. All right. Okay, guys. So like OSPF and let me. I'm skipping some terminology here. We'll continue OSPF complete terminology tomorrow. OSPF part 2. And today, directly let me show you the OSPF configuration. We have a two parts of OSPF, and part 1 is this. Part 2 tomorrow will continue. Now let me show you the OSPF configuration. Before OSPF configuration, let me ask something. DSM. What is meant by DSM? What is CSM? Default subnet mask and customized subnet mask, right? We know about default subnet mask, customized subnet mask. But now, today, we are going to learning about one new terminology. Terminology is a wildcard mask. That's the topic. The wildcard mask. Global subnet mask. Global subnet mask minus is wildcard mask. The part. Let me see now what is a global subnet mask. Global subnet mask is 255.255.255 subnet mask. It can be class A subnet mask or class B or class. Example, class A 255.0.0.0. Are you getting the answer? 255 minus 255. What? 0 dot 255 minus 0. 255 dot 55 dot. So this is a class A example. Class A wildcard. Now what will be the class B wildcard mask, guys? Class B wildcard. 0 dot 0 dot 255 dot. Okay. Class C wildcard mask. 0 dot 0 dot. So this is an example for default subnet mask. What about if I have a customized subnet mask? Like 255 dot 255 dot 255 dot 55 minus 255 dot 255 dot 255 dot 240. Answer 0 dot 0 dot 0 dot 15. The welcome. The example for customized. So to configure OSPF, as per OSPF terminology, we need to use wildcard mask. So when you're going to configure OSPF, we have to use what? Wildcard. Okay. Now I can copy it clearly. So wildcard mask is inverse of subnet mask. Why we use wildcard mask is a question actually. What is wildcard mask means? It's inverse of subnet mask. Simply you can say mask manager, subnet mask manager. To match each and every octet, first octet, second octet, third octet, fourth octet. Each and every octet to manage it, we use wildcard. So we have a clear explanation about wildcard mask when our security topics are being started. We'll discuss about real and wildcard. Okay. Copy it, guys. Now let's see configuration. OSPF configuration. Router configuration mode. Router OSPF. We have to use process ID. ID number also 125,535. In between you can use any number. And router mode, network space, network ID, space, wildcard mask, area ID. Network ID, wildcard mask, area. So what is area ID? We have the OSPF part 2. In OSPF part 2, we'll clearly discuss. And in meanwhile, default area ID is area 0. Area space 0. Example, in router configuration mode, so for example, let me explain it. What is the process ID? Router OSPF process ID 1,265,000. Any number you can use. It is only to start OSPF process. What is mean by exactly mean? At present, in my computer, in my laptop, IP routing command is already enabled defaults. You no need directly can configure. If it is disabled, then IP routing is required. Here, in my computer present, some applications are running, some process is doing right. And even some services are running in my processor. Let me click on services. These all services are being processing, running right. Each and every service is being processing by using one number, one ID called PID. Here, PID, right? PID is a process ID, service process ID. 22688, 22644, 21488. Like each and every service, you have one ID number is there. Based upon this number, your processor is going to process it, running it inside. So these numbers are being automatically generated by your operating system, Windows operating system. But when you're configuring OSPF in router, that number we need to define. Can be any, can use any number. Okay, only for to process the stuff. Router OSPF, example OSPF process ID number 123. Router configuration mode. Router mode. Network space, network ID. 192.168.2.0. Network ID. Next is what wildcard mask. What will be the wildcard mask of this IP address? 0.0.255. Space area. Area ID 0. Like this. Okay, guys? Just simply can use what extension router release mode. Show IP route. Router release mode. Show IP route OSPF. Router release mode. Check OSPF. Hello packets. Privilege mode. Debug IP. OSPF. Hello. That's it. OSPF neighbor table to IP OSPF neighbor. Check OSPF router ID and database table. Show IP OSPF database. Copy it now. Okay, let me configure in our topology. I'll show you. R1. So open your routing table. Here, three directly connect books. Router OSPF cross ID 123. Network 60000. Wildcard mask 0255255255. Area ID 0. Okay, wait, I'll show the previous slide. Network 80000. 0255255255. Area 0. Network 192.168.2.0. 000.255. Area 0. So OSPF configuration is finished in branch office 1 R1 router, right? So I have configured only the directly connected networks. Other routers network information is not required. Only inside the internal router networks only enough. Which IP address? Router is already configured. Branch 1 is configured, right? Now we configure the branch 2. On branch 2. So IP. There already static routing is there. If static is already there means OSPF does not work. Let me remove the static routing. Let me copy this routing. No command and paste. So IP. Now I have only three direct link networks. router OSP of cross ID. So R1 cross ID is 1 to 3, right? And head office also you can use 1 to 3 also, or can use what? 4, 5, 6. Any number. It can be same or it can be different. No problem. No issue. So my example is 4, 5, 6. Network space 10,000. Wildcard mask 0255 area ID 0. Second network 60. Third network 70. Now R1 router, R2 router, neighbor is been found. We confirm R3 also. Even R3 we have static routes long back. We have configured static. Let me remove it. No command. Show IP route. Now we have only directly connect networks. Let me configure OSPF here. Router OSPF. Source ID. Can use any number. Example 789. Network 70,000. 0255 area 0. Network 80,000. 255 dot 02. Wildcard mode. The last network 192.168 dot 0. 000 255 area 0. So now if you check show IP routes routing table, we can have OSPF has been updated. Right? So this is a 110 AD value administrative. What is 65 cost? Bandwidth cost of OSPF. Like how 65 is been came, that calculations will continue with the next session. Not hop count. So hop count is an RIP protocol. Huh? This is the cost. If I configured OSPF, not hop count. The bandwidth, link bandwidth. Okay, guys, all of you is clear. So that's for today. And the same topic will continue with tomorrow also. Try to practice about OSPF configuration really multiple times. And we'll continue the more detailed explanation about OSPF protocol and what is area ID, what is area 0, and OSPF multiple area, single area, OSPF election process, and hello packets, packet types, router types. Like we have a lot of terminology in OSPF. Discuss. Yeah, 110 is a administrative distance. Area value. And I'm sharing my contact number. Have any doubts? You can text me. Yeah, Pradeep, OSPF only. And in what OSPF? Any more doubts, guys? Sunnis, Salman, Sahil, Ram, Satish, Kumar, Pradeep, Shiva, Prasad, Let me show you the routing table entry. IP. What do you have done? Any routing protocol in RIP or OSPF, EIGRP, BGP, any routing protocol. Once routing is done, we'll open the routing table. What we need to focus on routing table is a very important point is like this type of fact. So this information we need to more focus on it. Very, very important point. I mean to say it like this. This is it. So what information are here? The first value is a administrative distance of protocol. RIP administrative distance is a fixed, say 120, SPP is 110, and the EHRP is a 9. And second value is a metric, metric of RIP, metric of protocol. Metric of RIP is what? Half count. Metric of OSPP is what? Metric of EHRP is a, yeah, bandwidth. Fast R, it can be what? Bandwidth. And EHRP is A1 and A3 value. Terminology. So as he asked what information is a 110 by 180 is, 110 is a AD value, 128 is what? How 128 is came? That we have the next session we'll discuss clearly. And with calculation. If we see the RIP here you can say 120 by 2. 120 is RIP AD, 2 is what? Half count. This for RIP. This for what? Oh yes, this one. Here Vinas. Yes, please. Yeah, Minas, instead of typing, you can unmute your mic.
Actually, I got it.